I am going to go ahead and do each of the three rules algebraically as well. I will go through these pretty fast, the other two pretty fast, because we've already done algebraically with the right-hand rule in example 1. I'm going to add in a left-hand rule and a midpoint rule, and I'll do that pretty quickly when I go ahead and do that algebraically. So let's go ahead and do that algebraically. So what we saw is that the area, well, I broke this up into 6 subintervals. We have these subintervals here. The area is a sum of 6 rectangles. And I used the right-hand rule to approximate the area. So with the right-hand rule, the approximation gave me 4.375. So the right-hand rule approximation is 4.375. Let's look at the left-hand rule. Now it's going to be real similar to the right-hand rule, except I'm going to use the left-hand values of my subintervals. I'm going to use 0, 0.5, then 1, then 1.5, then 2, then 2.5. Some of those I already know. Let me copy and paste some things. Let's go ahead and use the left-hand rule. Some people will call this the left side rule. F of 0 times the length of the first subinterval. F of 0.5 times the length of the second subinterval. F of 1 times the length of the third subinterval, or the width, I keep saying length. F of 1.5 times the width of the fourth subinterval. F of 2 times the width of the fifth subinterval, and F of 2.5 times the width of the sixth subinterval. Again, we're just taking each of these subintervals algebraically, and we're peeling off the left-hand value. You'll notice that a lot of these left-hand values were the right-hand values of the subinterval previously. So we plugged in 1 earlier in the right-hand rule for our second rectangle. Now I'm plugging in 1 for our third rectangle. Plugged in 2 earlier for our fourth rectangle. Now I'm plugging in 2 for our fifth rectangle. And the only reason I point that out is because a lot of these numbers, like F of 2.5, I've already calculated as F of 2.5 is 1.25. F of 2 is 2. F of 1.5 is actually 2.25. We already calculated that. F of 1 is the number 2. F of 0.5 is 1.25. It turns out F of 0 is 0. That's pretty easy to calculate. Plug in 0 into my function. You get 0 out. And if you calculate this, it turns out this also is an area of 4.375. Therefore, the left-hand rule approximation is also 4.375. Let's take a look at the midpoint rule. Again, we are going to do a very similar thing. We're going to look at a sum of 6 different rectangles. This one, though, I'm going to use the midpoint of each of these subintervals. Algebraically, the midpoint being halfway between gives me 0.25 for the first subinterval, 0.75 for the second, 1.25 for the third, 1.75 for the fourth, 2.25 for the fifth, and 2.75 for the sixth. Let's plug that in, 0.25, 0.75, 1.25, 1.75, 2.25, 2.75. Those are my 6 heights there. This takes a little bit more calculation. We haven't calculated f of 0.25 or f of 0.75 yet, but you can plug it into your calculator into the 3x minus x squared. I'm going to go ahead and do that. When you plug in f of 0.25, you get a 0.6875. When you plug in 0.75 into the function, you get a value which is 1.6875. When you plug in 1.25 into the function, you get a 2.1875. When you plug in a 1.75 into the function, you get a 2.1875 again. When you plug in 2.25 into the function, you get your 1.6875. Notice we kind of matched here, we matched there. And the last one, 2.75, you probably guessed this, is going to be a 0.6875. Now we want to add all of these rectangles up. That's something you can just plug into your calculator. I'm going to go ahead and do that on my own. I'm not going to show the work or anything. I'm just going to do that on my own and get out an answer. What I got out for my area was 4.5625 as an approximate area. Therefore, the midpoint rule approximation gives an approximate area of 4.5625. Notice that we are getting close to the same values in each of our rules. Our left-hand rule approximation and our right-hand rule approximation both gave 4.375. Our midpoint rule approximation gave 4.5625. So they are very close. I would like you to pause the video and approximate the signed area of our function g of x on a closed interval from 1 to 5 utilizing 4 rectangles. Try all 3 of the rules that we talked about. Try the right-hand rule, try the left-hand rule, and try the midpoint rule, all with 4 rectangles.